All right, now I'm going to be doing page 151, numbers 81 through 83. All right, you can use a graphing calculator on this one. All right, you may use a graphing calculator to solve the following problem. So that means whenever it asks for anything, we're just going to estimate it. Okay. All right, a particle, so 81. A particle moves along the x-axis so that any time t is greater than or equal to 0, its position is given by x of t equals t cubed minus 12t plus 5. Okay, so it's just moving along the x-axis, and this is how far along it is on the x-axis given the time. Okay, find the velocity. All right, well, the velocity would just be v of t, which is x prime of t, which is 3t squared minus 12. B, and then a lot of you had stuff plugged in, but it says at any time t, so that's it. You don't plug anything in, just any time t. Find the acceleration. Well, a of t is v prime of t, or x double prime of t. So then that would just be 6t. Okay. Find all values of t for which the particle is at rest. Okay, so that means that the velocity is 0. All right. So that would be 3t squared minus 12 equals 0. Okay. So then you just plug that in. So that would be t squared equals 4, just out of 12 divided by 3. So t is plus or minus 2. Negative 2 doesn't make any sense, so just t is 2 seconds. Okay, because they say, oh, do they even tell me it's seconds? It's given by particle moves along the x-axis, time t, its position. No, so they don't tell me if it's seconds or not, so I'm not going to put the units. Don't assume that. And then we'll box that. Okay. All right, D says find the speed of the particle when the acceleration is 0. So I'm going to set 6t equal to 0, which means t equals 0. That's time, though, so that's not the answer, okay? It says to find the speed. So speed is the absolute value of 3t squared minus 12 when you plug in t equals 0. So that would be 3 times 0 minus 12, which is 12. Okay. E says, is the particle moving toward the origin, away from the origin when t is 3? Justify your answer. So a lot of you did the v of t part. So t equals 3, and I'm going to say v of 3 is 3 times 9 minus 12, which is 27 minus 12. So that's positive. Okay. So, but that doesn't necessarily mean that it's moving toward it does mean that it's moving right. So, but in that one that we did in class, it is moving towards the origin. If it was below, it would be moving upward. Okay, so that would have been toward the origin. So you can't just say for sure just because it's positive that it's moving toward the origin. This is just moving right. That is true because it's along the x-axis. Well, if you want to know if it's toward the origin, it really depends on where it starts. If it starts to the right of it at t equals 3, if it's already past the origin, moving right would be farther away from the origin. If I'm on the left, though, it would be toward it. So how do I tell that? Well, I plug in x of 3 to find its position when it's 3. So that's 3 cubed minus 12 times 3 plus 5, which is 27 minus what? 36. So let's just see. I'm just going to put it in. I don't know why I'm doing this in my head. 3 cubed minus 12 times 3 plus 5, and I get negative 4. So this is starts, so it's left of origin. Moving right. So it's moving. Yes, it's moving toward origin. I think, what did it say? Find the speed. Is the particle moving toward the origin? Yes. Moving. Yeah. So yes, it is left of the origin, but moving right or toward. Yep. All right. That's 81. 82. So find the function f is differentiable. Find the function f is differentiable for all real numbers and satisfies the condition g of x equals f of x over f of x minus 3. Okay, now you can't split this up and say that's 1 minus f of x over 3. You can split up a single denominator to multiple numerators, but not vice versa. Okay, so you're stuck with this. All right, and then they give us this chart. 2, 4, f of x is negative 1, 3, and f prime of x is 3, 5. Okay. Now they say, write an equation of the line tangent to the graph of f at x equals 4. Okay, so I need tangent to the graph of f at x equals 4. Okay, so g of 4 equals f of 4 over f of 4 minus 3. Oh, but I just want, hang on, line tangent to the graph of f. Sorry, I don't want g. I want tangent to the line of f. So I want f of 4, I want y minus y1 equals m times x minus x1 for f. So this is going to be f of 4. So y1 equals f of 4, and x1 equals 4, and m equals f prime of 4, which they give us. So I just do y minus, y1 is f of 4, which is 3, equals f prime of 4, which is 5, times x minus 4. All right, and then they say, lost my place, is f continuous at x equals 3? Yes, well, they say g is continuous. Is f continuous at x equals 3? Yeah, at x equals 3. Well, is f continuous at x equals 3? Well, I would need to know if it's differentiable at x equals 3. Okay. Let's see, is there... Well, what's g prime of 3? No, you can't do that. Equals f of 3. Oh, well, yeah, they say f is differentiable to all real numbers. Yeah. So that was it. It's just up in the instructions. Yes, because it is given that f is differentiable everywhere. Therefore, it is continuous. Right? So they ask, yep, everywhere. That does not go the other way. If it's continuous, if it's differentiable, then it had to have been continuous. But just because it's continuous does not mean it's differentiable. Okay? All right. The next one says, is there a 0 of f on the interval 2, 4? Justify your answer. All right, well, if you look at x equals 2, you get -1 for f, and 4, you get 3. So if you, from -1 to 3, you have to pass through 0 if f is continuous. So yes, since f is continuous, now that's really important, and a lot of you left that out. Everywhere, well, it's continuous on, specifically, on 2, 4, and since f of 2 is less than 0, and f of 4 is greater than 0, then by the intermediate value theorem, and don't write IBT, write it out, we're practicing for the exam, f of x equals 0 somewhere in 2, 4. So a lot of you didn't say the continuous, and a lot of you didn't use the words intermediate value theorem, and that's really what they're looking for. But you'd get the majority of the points just by saying continuous, and if it's negative then positive, it's got to go through 0 because it's continuous. The intermediate value theorem is just like some added bonus there. Okay, is there oh, we already did that one. D says to find g prime of 2. Okay, well, I got to do t is f of x. I'm going to do t prime is f prime of x. B is f of x minus 3. So b prime is f prime of x again. So then I get f prime of x times f of x minus 3 minus f of x, f prime of x, all over f of x minus 3 squared. Then I'm going to plug it in, x equals 2. So f prime of 2 is 3. F of 2 is -1 minus f of 2, -1. F prime of 2 is 3. All over f of 2 is -1 minus 3 squared. So then I get 3 times -4 plus 3 over 4 squared, so 16. So then that's 12, 11, 10, 9, so -9/16. All right, E says, explain why g is not differentiable at x equals 4. Okay, well, because since f of 4 equals 3, then the denominator of g of x equals 0 for x equals 4. Therefore, g of 4 does not exist, so it is not differentiable. Something like that is fine. You don't have to say precisely that, but mostly just that, like, the denominator is 0. Okay? Try not to use the word bottom. I saw that a lot. Use the word denominator. All right. 83. Let f of x equal cosine of x over cosine of x minus 2. Negative 2 pi is less than or equal to x, is less than or equal to 2 pi. All right, sketch a graph. Okay, this one we went over in class. You just graph it, literally, on your calculator. So y equals, so I do alpha y equals enter, and that gives me these like fraction things. If yours doesn't do that, make sure you put parentheses around your denominator. Cosine x over, so if you don't have this fraction bar, you need to put parentheses, cosine x minus 2, close parentheses. And you still need to close the parentheses around that x also. All right, and then I do zoom, and then I pick trig. All right, and then they tell you the window. So the x ones are negative 2 pi to 2 pi, negative 2 pi to 2 pi, and I told you I like pi over 12s. So that fits everybody. And then I want negative 2 to 2, and I'm going to do a scale of 0.5 just because I want to. Because they didn't demand the scale, so that was fine. Okay. So that's 6/12, so that's pi over 2. So I bet, let me change that because I don't want to draw so many tick marks if I don't have to. So I'm going to change that to pi over 2. Oh yeah, it goes nicely through. So I don't need the pi over 12. Pi over 2 is just fine. So I expect for you to play with your window some. Make it pretty. Okay? All right. And then you draw exactly that, and you label this as pi over 2, and you label that as negative 1. I just would label that one. Okay? Or label that one as positive 1. But you draw exactly what you have in the window because that's what they said. Okay? I'm not doing that one. All right, B. Find f prime of x. Okay, well, the top is cosine x, and the bottom is cosine x minus 2, t prime, s, c. So it's the derivative of cosine is negative sine x, b prime, negative sine x. So then f prime of x equals negative sine x cosine x minus 2 minus negative, so plus sine x cosine x all over b squared cosine x minus 2 squared. And I counted it right if you stopped here. But I would like for you to notice this. If you distributed this, this is negative and this is positive, so this cancels with this, and you just get this one. So that's just 2 sine x over, that's just 2 sine x over cosine x minus 2 squared. All right, C. Find all values for the domain for which f prime is 0. So in the domain, so that was like in their given domain. So just negative 2 pi to 2 pi. All right, so just set that equal to 0. Well, that would be 2 sine of x equals 0. So sine of x equals 0. And where does that happen? Well, sine is the y value. Where is y 0? Here and here. That's 0, pi, 2 pi. Okay, or the other way, negative pi, negative 2 pi. So that's your answer. X equals 0 plus or minus pi plus or minus 2 pi. Okay, you could also graph the derivative. Okay, you just type this in and graph it and then find all the places that it's 0, okay? If you didn't want to use your unit circle, if you didn't know how to, then you just literally graph the derivative. So I'm going to turn this one off because I don't want to delete it because I might need it later. I'm not sure. And then I would just graph oops, y equals there we go. And then I would just graph 2 sine x over, let me go close that, over cosine x minus 2 squared. And I'm going to leave it in that same domain because that's what they said. Now this is the derivative. So this is a picture of what the slope is doing. Okay? Which is interesting. Okay? And where is it 0? Here, 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 and here. And I counted by pi over 2's. So that would be negative 2 pi, negative pi, 0, pi, 2 pi. And that would give me my answer without having to know anything about my unit circle or anything. You just graph the derivative and find its zeros. Okay? Use the information obtained from parts A and C to find the range of f. Well, okay, so I'm just going to go back here. And I'm going to turn this on. And I'm going to turn that off. And then I'm going to hit graph. Now, I don't know why they want us to find the information used in parts A and C. Okay. I mean, this is the extrema, so I could plug that in. And that would be my highest and lowest points. Okay. Or I can just do second, calc, value, which you can do analyze graph on the inspires. You just go menu, analyze graph, and then you just value, I think. I'm not sure which one you do on that one. But it is under analyze graph. Okay, and then I'm going to plug in 0. And that gives me negative 1. So that's the lowest. And then I'm going to plug in, what is that? Pi? Oh yeah, pi. See? So now I'm going to put second pi. And you just do it and it'll do the next one. You don't have to calculate again. And that's 1/3. And it actually gives me as 1/3, but if it gave 0.333, write it as 1/3 if you know. So negative 1, oh, this is D, to 1/3. Okay. All right, and that's it.